Paresh, are you able to see my screen?
Yes.
Excellent. Hello, everyone. My name is Surbhi Pokharna. I'll be talking here about Snowflake, data efficiency, databases, tables, views, time travel, a couple of other aspects, and to begin with concepts and architecture. And this is quick intro about myself. I'm a data professional with 20 plus years of experience. Currently, I'm involved with the cloud data migration and leading a global data platform services team. I am one of the board of directors for New England SQL Server User Group in Boston. I have spoken in user groups, past summit, data Saturdays, SQL bits. And here is my contact information. The best way, if you have any question after this session, you can message me via LinkedIn or my Gmail address, or you can message me via Twitter. So that's the LinkedIn is the one I keep an eye. And the Snowflake considerations. Okay. So what? Let me just bring everything here. And so based on this meetups, there were some questions after this session was announced. I understood the audience we have mixed because this user we are heavily engaged or involved more with the SQL Server side in Snowflake. So few people might have like more understand, like looking forward for like what are the concepts in architecture before we just jump on the database tables and all the demos. So what I will be doing, like from at least 15-20 minutes, I will be completely focusing on concepts, architecture, and enable you to get started. Tomorrow, if you think that, okay, I just want to learn a little bit more, and then how do I start? What do I do? What is the first step? So we'll start from there. You cannot run when you do not know how to walk. So we'll start learning to walk, and then we will move towards our demos about more detailed aspects. So when you start your journey, these are the considerations or the verticals of the layers of foundations we would be starting with. So here we would be covering about what is Snowflake, billing model, additions, web portal. Then we will understand the architecture, data processing, virtual warehouse, micro partitions in the table structure, type of tables, what is time travel, what is clone database, what is the meaning of data sharing, some of the data loading, unloading, that aspect we would not go. Slightly, we will touch data security, not too much. And on the journey, because now we are DBA virtual user group is more, we all are SQL Server wizards, so we will be keep doing a little bit of SQL Server comparison also, just not for the sake of what is good, what is bad, or who is superior and all. No, that's not the objective. We'll compare from like just sometimes you know one thing, you are learning something else, and you just build that connection. It helps us to remember things longer from that perspective. So to begin with, billing model, addition, and web portal, that all would be part of demo because that's a pretty quick thing. And when you would be starting with the Snowflake. So as typically you must have heard, the Snowflake is a cloud database. It's not here in on-prem. Snowflake is a cloud data platform kind of thing. So what is called? Actually, Snowflake in one line definition is a fully managed cloud database data platform. So what does this mean by fully managed? Fully managed means it is you can compare from the SQL Server side or in the Azure world how the Azure SQL database is. So this is basically deployed by the vendor. In this case, it is Snowflake. You as an user would not have any access to operating system or the hardware, and there is no component administration required. So when you do not have access, even access or visibility to the underlying hardware, you do not have to worry about the patching or any of the other aspect. And when I say fully managed, there are a couple of other things also. Indexes, because there are no indexes in Snowflake. When we go further, we will understand. So since there are no indexes, obviously you don't have to manage the indexes or maintain the rebuild index part. There is statistics underneath which Snowflake is managing at their end. So you don't have to worry about that. Queries, you are writing queries, you want to tune the query, you want to get it a little bit more in an optimized manner, you might be making a call to Snowflake, creating a ticket, and they would be helping you with the query tuning. So when the fully managed aspect comes, Typical database administration management is very less comparatively. That is so that is why it is called a fully managed. Then when we call it cloud, what do we mean by cloud? So the big differentiator for Snowflake, or how it stands out, it is more, Snowflake is cloud agnostic. So that means that Snowflake would work in AWS, Google Cloud, and Azure. But not only that, let's say I have a Snowflake deployment in Azure. Then I want to maintain a single source of truth. And we have some clients or some data spread in AWS, Google Cloud, or you might want to share the data with some other client who might be in AWS. Then with the single connection, like a Snow Grid, you can have, like, sorry, with the single functionality or the type of massive networking capability that is called Snow Grid, you can maintain a single source of truth in one cloud and share the data across multiple clouds. And Snowflake is cloud agnostic, so you can have your various deployments in all these various cloud platforms underneath. That would not matter. So that is the one big differentiator for Snowflake, where people are picking, like, Fabric versus, like, why do I go for Snowflake? So this, so far, it is turning out to be one of the huge differentiator. Moving along, so we understood what is fully managed, we understood what is cloud. Now, what do we mean by data platform? So the data platform is, what do we understand from the data platform? That if you have to build a data solution, you want to have a data warehousing capability, data lake capability, data processing capability, application development capability, data sharing capabilities, and we'll come to the data sharing, especially in a different, like, more spotlight on that aspect as well. But all these capabilities, that means that you just do not need that you want to create a database, right? You want a platform where you can build solutions. So you need much more than all the like integrations should be there for you to be able to build your data solution and be able to handle your workload. And also, when you build that, one another aspect where the Snowflake would stand out because of the data sharing capabilities. What does that mean? That I have COVID analysis data. John Hopkins was releasing that. Many other companies and analytics companies were releasing countrywide or across the globe, statewide, townwide. And all that data is something that, there is a company which is releasing the data, and then there are 10 companies, they want to buy that data. Similarly, the financial data. In the stock market, there are certain type of data which typically all the financial services companies might be using that. So they might be getting all the feeds, or they might be getting the pull, taking the data pull, or from the some shared location. So the Snowflake can create a share, a secured share with those various companies, whoever is are looking for data, and they can sell. Even we build our own some small bundle of data, which is that we clean the data, we make it like all the data, clean all the dirty data, and then make it like some solution. And you just want to share that particular piece of data so that someone else can build their data mart. You can have that available for the data sharing. So data sharing is another unique aspect which makes Snowflake stand out. Now, what is Snowflake architecture? These three layers, let's spend some good 5 minutes on this, because this is the core. Once we understand that, we go towards demos and all, you have like a fair idea what's going on everywhere, everything. So the bottommost layer is data storage. That's where, when the data is loaded in Snowflake, Snowflake would reorganize that data into its own internal optimized, compressed, columnar format. And this one, Snowflake would be storing this optimized data in cloud storage. So if you are on
Typed a
Azure,
message in the chat.
excuse me.
I typed a message in the chat.
Oh, Paresh, is there any question?
Yeah, I'm just looking for a data analyst.
Sorry.
Typed a message in the chat with my phone number.
Let me see what is there in the chat. What?
He was looking for a job. or he was giving a job, and we can't have that discussion. I told him not to do that. So, okay,
Okay.
sorry about this. Take care.
No, yeah. So coming back, so the data storage is Snowflake is managing that. So even if let's say that you are deployed in Azure and you have underneath blob storage or the premium SSD V2 or Ultra Disk, that's Snowflake headache. It's not your headache. But how it is doing that? So the bottommost storage layer is managed by Snowflake. How they are compressing the data, how they are storing the metadata statistics, and how they are handling the whole thing, that is up to them. So it is not directly visible or accessible by customer. In this case, we are customer, right? Because this is the functionality what we are getting. So we can query, even though like there are options where you can query and you get some idea about the performance pieces. The next layer is query processing. That's where all the fun is happening. Query processing means not like in our case, you have to update the statistics in some tables in SQL Server, which is heavily disk IO intensive operation, which would work on the table, and each table, whichever you are updating the statistics based on the percentage of whatever the sampling you're picking, all that is taken care of by Snowflake. In this case, at the same time, it is when we do update the statistics and there is a disk IO happening, then if you are in Azure or any cloud, your billing is going on. Your compute is going on, CPU, memory, and all that. In Snowflake, query processing means your business. What you are doing, your select of your application tables, inserting the data, updating the data, loading the data, that is all meant by query processing. And for that, whatever the compute you need, it is called in our older terminology, CPU, memory, disk IO, and all that, right? Here it is called virtual warehouse. So the unit of compute is virtual warehouse. That is being assigned. So by default, when you create your Snowflake account, you will have a by default one virtual warehouse created with the minimum capabilities. Well, you can have a single cluster virtual warehouse, multi-cluster virtual warehouses, and you can have even one database. Does in the morning you load tons of data in that particular schema, I'm calling it that like that way, and in the second half of the day you do some data processing, run some reports. So both operation need separate kind of compute capabilities. You can create two virtual warehouses and you can assign these two different schemas, those two virtual warehouses, or table wise in the landing zone you can have a different virtual warehouse which is giving it like a higher bandwidth capability, compute capability, because you're dumping tons of data. And during the day, you are running a small scale report. You don't need a big fat, virtual warehouse or the compute power. You can have a smaller one. So there are a lot of options, and then you can have and we'll go through the architecture in that, what is MPP and all that. But this is the layer where all the billing, you would see that a lot of billing is actually based on your virtual warehouses. You have performance issues, you need to add more virtual warehouse, create another virtual warehouse and assign, move your table from which is causing like which is the slowness, you move from the one virtual warehouse to another so that it can get its own dedicated resources. All that is typically from the data management perspective. Like if you think about the DBA role, what would they be doing in Snowflake case, right? So these are the things performance perspective a data management person would be keeping an eye. So this is query processing layer. Third layer is cloud services. Cloud services means you have statistics, somebody is updating your statistics, metadata, who logged in, which query executed, all the performance of queries. So all that thing is a separate unit of compute and storage, which is handled and completely managed by Snowflake, and you are not charged for that. There is no cost for you for that. So in that case, obviously, who should have authentication and who should have access control? We as a user of our own organization and owner of organization, we decide. We decide roles, who should have what kind of privileges. But when you are creating roles, when you are assigning those roles, all that thing is not going into the compute second layer, the query processing layer. All that is being taken care of by cloud services. So your virtual warehouse would only be in use when you are actually doing some work. In that case, the cloud updating the statistics, whatever the compute it would need, it would go from cloud services. So when you create your Snowflake account, by default, you get two databases, Snowflake and then another Snowflake with some sample tables. So sample tables is more for your like playing around and everything. The Snowflake database, which is the one which you get, that is the one which would be keeping all these metadata tables, all auditing tables. Moving along. When we said the data processing, the virtual warehouses, so the Snowflake architecture, it has three main properties: massively parallel processing database engine, MPP. That means it gives the compute power by adding more nodes. So you can add more nodes individually, more powerful you can make it, and also you can decouple. Storage and compute is decoupled. This is one of the very important, like this is just a single line statement. But if you are if you are, let's say that you are in Azure and a VM in IaaS, or you are running in managed instance. The very latest, like in the, it is still in the public preview with managed instance, but I think Microsoft is also moving towards isolating the compute and storage. In only in hyperscale, Azure SQL database hyperscale, that architecture is being implemented. So the point is, in virtual warehouse where you have compute and the storage is underneath layer, just in case you have some kind of disk pressure, that doesn't mean that you will add more CPU. So these are the two different aspects. Whereas if you are running a SQL, you're running a SQL server on a VM in IaaS, and you need your VM also comes with its own pre-assigned bandwidth and throughput and IOPS numbers, and your individual disks are also like that. So if you have a disk needs, your workload needs higher IO, even if you do not need CPU, you might be moving to the next VM just in order to get more IO. That means that the compute and storage are not decoupled. They go hand in hand, and you end up paying a lot more money for your SQL licenses. In this case, compute and storage are two different worlds. So that's why there is no connection with the performance issues. Virtual warehouse add more compute, and storage is separate aspect. Okay. And you can add more cluster nodes. That would obviously, there are billing in bill, there is billing involved with that. It's up to you. How do we add more clustered nodes in your virtual warehouse? That we'll check that in our demo. Virtual warehouse operation. This is, as I mentioned, this is your operation, what you're doing. Your select, your insert, update, delete, copy. That's like a typical your own business. That's where the virtual warehouse compute would be charged. And credits or store nodes. By default, I get an extra small virtual warehouse, like you can say 4 vCPU kind of setup with the 1 per hour, and Snowflake billing is per second. So we are not going in, cost is like a completely different aspect to go in detail. And then you have a virtual warehouse, you create a small size, you get 2 clusters, you get medium, so you can keep adding more clusters in your. And the one good aspect is you can have auto suspension or auto resume. That means when you create your virtual warehouse and you're not consuming that, it is same as pay as you go, right? It would be, you can have auto resume options. When you're not using that, it will not cause you any credits in your billing account. Okay, so let's create some, understand the addition, everything via demo. So let me move my other screen here. Give me a second. Where's the other screen go? Okay. So you go to Snowflake. You want to get started, right? So this is we start our journey. Pretty simple. Start for free. That's your $400 credit for 1 month, which is again pretty cool. You can do that. And this is the screen where you get all your options of Snowflake editions. This is very important screen because this one is sets the tone about your edition, which is standard, enterprise, business critical. By default, enterprise is selected. And when it says the standard, whatever is standard is giving you all the features and 90 days time travel. That means I can go back up to 90 days in the history. If I create a table, regular table, and then I drop that by mistake, then I can go back up to 90 days and I can recover the data. And we'll do that in demo with the time travel and other options. And if I drop a database, again, I can go back up to 90 days. But that is up to. How do we actually do that? We'll see that in demo. In the business critical, you get way advanced failover, failback, and other enhancements from the security perspective. For our demo purposes or for practically all practical purposes, you are good with Enterprise Edition. And then you pick your cloud, which cloud we want to pick. So like, let's say that if I do the Microsoft Azure, then you have to pick your region. Now, this is, even though it looks pretty simple, by default, there's a Canada Central, Toronto is selected. If your business is running in East US or an US region, accordingly pick the region. Otherwise, there will be some inherent latencies underneath and unnecessary it would bother, and add your performance issues in your workload. So these are the considerations you would be doing while creating, while your free account and picking your editions, and you will get started. So this is the first step which you would be doing. And enterprise edition, region, Microsoft, whatever you want to pick. Now let's say I did that. So I get my this. Let me come back to. Okay. So this is my world of Snowflake in browser-based Snow site, where you get all the options to run your to create your databases, create your objects, create multiple kind of data shares, and do whatnot. There are other options from the data loading, unloading, where you would go with the external sources. How we get the external sources and data loading, unloading, that's another aspect. Any questions so far before we get into the creation of databases and tables?
No questions.
Okay, very good. You still see my screen, right?
Yes, welcome to the universal search.
Yeah, okay, good. Yeah. Now, what in this Snow site, this is my account, and I'm account admin. So there are certain type of roles which are built-in roles. Account admin is as good as, from the SQL Server perspective, is your super user. So I am super user of this account, what I have created. What are the other roles when I go with that? Org admin. Org admin is kind of your CFO. If suppose your organization is running 20 Snowflake deployments in development, UAT, and production, your CFO should be the org admin who wants to see all the accounts, so that per account, how the dashboards from the billing perspective is happening, they can see that. From database administration perspective, also in a certain cases, we would like to be org admin, so we can see that how performance perspective if we have something. But typically Snowflake performance issues are very very specific and different, and that is again like a completely a different talk on its own. So account admin is more than sufficient. You are the super user DB sysadmin here. Public is the by default, which is minimum permission. Security admin is more about, you can have all your governance team. They might be where you want to have a data masking, and you want to make sure that roles are different, DBA and security, and then they would be, your security team would be getting security admin access. Sysadmin is not same as SQL Server sysadmin. Sysadmin is more within the database and the schema, you can have higher privileges. And user admin, if you are just managing all the roles and users and customized permissions, etc., then that user admin. So in this current case, account admin is our profile. So that is the permission. Afterwards, okay, so then Snowflake documentation, if you're looking for, there is a doc.snowflake.com, and you will find all the documentation, lot of virtual labs and everything, user guide. There's a lot of things you would see that I'm taking from the database tables and views sessions. So this is sufficient for you to get started with your journey and then move towards the advanced level. Now, in this projects, you get you get your worksheets. There you can create your type of your demos or your scripts. You can share the scripts, like here you see that, if I select this one, I can share this with certain my team members. So they also would be getting, if I make the changes, they will get the changes in the scripts. So this is something like, all the worksheets are pretty cool. I really like that because it helps to manage your it is more like an Azure Data Studio kind of feeling. And so this can have all your scripts, databases. This is the main thing. We refresh that so that we can. So as I said, by default, we get two databases, Snowflake. It would give you a lot of information about your account uses, access history. As I said, like a lot of data security kind of auditing. Auditors would love to see a lot of information. So it gives it. Then this is the by default, you get this database. And then Snowflake sample data contains a lot of sample schemas for your work if you're going to use that. And any questions so far?
Nope.
Okay, so
You're doing an awesome job, man.
Okay, thank you. So I might be dropping this database pretty soon. So, but yeah, so we Snowflake and Snowflake schema. These are the two databases. Now what we do, next couple of minutes, 10 minutes, we will create database and we will understand what all type of database one can create. And now if you drop your database, how do we recover that? What are the options? Then we will create different types of tables. What are the options of each type of tables? Like even in SQL Server, you have temp tables, you have regular tables. So similarly, we have different types of tables. So let's get going with our worksheet for database and tables. And I think I've already dropped. Okay, this was the one database which was not dropped. Okay, so show database. Currently, we do not have any database created. So we get Snowflake and Snowflake sample data, which is the one which you get by default. What are the options? You can create a database or you can create a transient database. Now, two terminology. Let's understand that very well before we, and 1 minute, there's one more aspect which I should be showing you before we go towards that. In Snowflake, with show database, it is showing me like SP help DB, all the database properties. And here there is a column retention time. Now, since these are like sort of system databases, right? So retention is like forever. So 0 means forever. Nobody can drop that. It's going to be there. I'm going to create my database. What is my type of database? By default, when I create a database, what kind of time travel I get? And when I use the time travel terminology, right, from the SQL Server perspective, like the backup, right? How long I can go back to restore, that means how long you were retaining your backup. So that is what is time travel. And transient means that your database, you create your database, but your transient means that when you drop that, right? So it has its own life and it will be auto drop after 24 hours. But you cannot go up to the 90 days time travel because you have created that as transient. So that might be your staging database for whatever. You can keep creating every day, but it is not your regular database. So as I said, time travel, let me create one database and then show that. So I'm creating one database matrix. On this screen, this is the one where this is your working ground, right? So you can select the script. Like if I hover, just click here, create database. And in the setting highlight statement, I just select that. So when did I do that? No, yeah. So then I do not have to do the entire selection. I can just click on that particular line, and when you execute that particular, this on the rightmost the arrow key, it would execute that particular command. Since matrix already exists, it gave me that error. Here, the account admin is the user who is running this particular query, and the compute WH. This is my by default warehouse, which when you create your account, you get a by default single credit, single node virtual warehouse attached. And this is what is my virtual warehouse, which is extra small because there is no parallel processing happening here. So this is my work area. That's where I am. When you create your database, by default, you get time travel up to 5 days. So in the matrix database, in database properties, retention time is 5 days. In what edition we picked? Enterprise edition. That means I can go back up to 90 days. All I need to do is alter my database and change the retention time, and I can pick it up to 90 days, any number. Maybe I would do that for 10 days, whatever is your requirement. Accordingly, you can do that. So this is the one which by default it got created, and the retention is 5 days. Now, this is the, so that means that is the time travel up to 5 days. We have historical data. There is one more terminology called fail-safe. Fail-safe means up to 14 days, Snowflake support can help me to retrieve data. So let's say that, time travel 5 days, and then I drop the database 6th day, and I do not have any retention of the older data, and I need it like little older than that. So up to 14 days fail safe, I can call Snowflake support, and they can do this. They can provide me that backup. Would that be can be done with the transient option? No. So the fail safe and time travel is not available with the transient option. And the similar story would continue with the tables. That's why these two concepts and the terminology is important to understand. So now I'm going to create a transient database, transient matrix. So when you create the transient database, and I've already run the show database. So this is the transient database, right? So here it is showing the option transient, and the retention time is by default 1 day, and it will be auto dropped after 1 day. Now, if you have to do the, okay, now let's think about one scenario. We are working on matrix database, and you need to do some testing for on certain type of data, and we mess up with the data. And you want to create a, so before doing all your work, you want to create a clone of the database, keep that on the side, and then keep working on matrix database, and you messed up. Then what you want to, you can restore matrix database where up to a certain time. That means that point in time recovery, right? So this is something like at before. So what I can do, that I can go back, uh, 3 days ago, whatever the data was there, I messed up now. I need to go back 3 days ago on a certain time window. So I can create a matrix clone to database, and I can go with the matrix at before, and I can give the timestamp. So this command takes pretty long. That's why I'm not going to do that currently. But because I'm running that on like an extra small warehouse. But the point is, you can create multiple clones. And when we go back to our some, like what is the, from the architecture perspective, the cloning architecture is, if your database is a couple of terabytes, and when you're creating the clones, it is actually internally all the tables are creating pointer to the new table. They are not actually creating same 10 terabyte of tables, and we will understand what does that mean. Just keep that concept in back of your mind. But from the clone perspective, it gives you the multiple clone options with that add before or the regular clone. So add before helps that, I can have a 3 clone, right? This clone 1, add before 1 day, clone 2, add before 3 days, and then you can do the data comparison of all those things. So you do not have to do the transaction log, full backup, differential backup, restore up to that time, and then get that copy of the data, which is pretty tedious task when you do that. Okay. So now what I'm going to do, let me drop the matrix database, which we just created. and recreate this time with the retention of 10 days. So obviously your show database, it would show the retention 10 days. Now let's move about towards the creating the tables, and I'll show you why I said that. The tables what you would be creating, they inherit the retention from your database. So any database in matrix, any table in the matrix database would be now not would be creating by default 5 days retention. They would be there with the 10 days retention. Any question on database? See the chat. I think no question. So moving
Nothing.
along.
Don't worry, Surbhi. We are monitoring it, man. Don't worry.
Yeah.
Yeah.
So now the type of tables: permanent table, temporary table, transient table, external tables, and dynamic tables. So the permanent tables are regular tables, how we all know the tables are. Temporary tables are the one which are like same as the table which is saved in the TempDB, restricted to this session. I drop that table, you cannot get that. Transient tables are the tables which would be same as the transient database, that they would have a life of 24 hours. So when you create the transient table, you go to the another query window and do a select, you will see if data is there, then data, if no data, but at least you'll see the table. So the temporary table and transient table, based on your uses, you can pick. External tables are like how we have like the blob or the data virtualization. Similarly, you can have your JSON, Parquet, Avro, multiple type of formats, and you can create your external tables. Even you can build your relational database models using external tables. So the permanent tables, I'm just going like with the matrix. I'm going to create EMP employee table.
Surbhi,
Yes, sir.
I have a question. So this should be the opposite side of the SQL Server's external table, right? Like, is that a fair assessment?
Uh, External table would be opposite. Like, what do you mean by opposite?
Like in SQL Server, also they have external tables, right? So
Oh yeah. So in SQL Server, oh yeah, you're so right. Opposite means from conceptually, if you have a 20 terabyte of dumping ground kind of data, you create an external table and add a blob storage there, because you don't want that table to be part of your system. And here you have a relational architecture, and but sometimes we do create for the build. You want to bring on a daily basis type of like an Avro file, data loading, and in between you want to use some table, transient tables to do some data changes and all that. So it's a combination. But in nutshell, since Snowflake now via external table is supporting relational data models also, that is why I picked that. But at the same time, it would do the staging kind of job also. You can use that. But in SQL Server, more external tables we will be using for the bigger data, which is not the relational model, and you're bringing NoSQL kind of thing and then doing something, or you want to still query that data with the join, then you use that data virtualization aspect. Yeah, but yeah, concept high level thing, yes, answer is yes. So now I created this, did I create? Let me do that. So employee table. And when you do the show table, remember the matrix database retention, we changed that to the 10 days. So here, the employee table, what I have created, the retention time is inherited from the database. So it is all your data would be taking unless you go back and change something. See, all these things are important because when you start working, especially most of us wear data management hat also. So can transient tables be dropped? Actually, there's one question. If they have foreign key constraints. So the foreign key constraints, that is more the data model from the relational, right? So do not relate all these things. These will be the fact and, those dimension tables. So not necessarily there will be foreign key constraints here. But transient tables automatically get dropped after 24 hours. Okay, so moving on, and typically you might be designing transient tables more for the staging purposes, where you have this data should stay there. Like in your schema, 20 tables data should stay there. Retention 2 days, other tables 10 days, 3 tables transient, automatically keep changing. So you can go with the build your model accordingly. That is why now we still wear the DBA hat. that is such a myth that these fully managed databases, cloud data platform and whatnot, and we do not need DBAs. We do need still DBAs, but we need to wear our hat like little bigger hat, basically, from the various dimensions which are also getting added here than just that, like how we were looking at the SQL Server so far. Okay, so now we saw this one, and let me create one temporary table. This is temporary table orders. Currently, there is no data in that table. I'm just with the type of table is temporary table. So when I go and select from orders, fair enough, there is no data, but it is at least giving me the table structure. But when I go to any other query window and I run the same command, select from orders, it would be order does not, table does not exist, because that is a temporary table, right? Now I do the same thing. I create another transient table now. I create a transient table, transient orders in matrix database. So here, this is like a use database, right? These are the options what we have. So I have this in the matrix database, and let me create a transient table. Okay, so the transient table, if I go to the another query window and I just do a select from transient table, there's no data, but it understands because we are still within that 1 day. So the transient table is, you can still query that if there would have been the data, but you can access that from the other screens. So this is about your transient table. Now let me go towards okay, 1 second. Okay, where is the, okay, now employee table, when we created that, you have a, did we create employee table? I think we already have employee table in matrix database. Yeah, it already exists. So the insert is a bit different. You can have like a multiple inserts in a single statement, right? You don't do that one at a time. And now since my setting is highlighted statement is on, I just select here, automatically this is highlighted, and you can do the data insertion now. So we have an employee table. And now here at the same time, you can check your query, how many queries I'm running. This is all my query history. Up to last 14 days is by default available. You can have a like little longer also, that you will work with your Snowflake support and your edition and all those things. But by default, every single who is executing, which query is taking how much time, all that information from past 14 days end to end is available. So by default, auditing database level is on, table level is on, so that you can see all that information. Now, what we are going to do, I will, we have 15 minutes, right? And I want to go in the data sharing as well. So we go and let's try to do the clone table and then understand the cloning concept. And then we do the drop and undrop, right? Or how that would work. So let's create the, okay, you can do the clone within the database, cross database also. So which is also another cool thing, right? So give me a second, cross database. Now I'm creating a clone matrix database, which is cloning from the matrix database. Fair enough. So we get one more database, clone matrix. And matrix database, we just inserted some of the rows in employee table. I want to create this employee 2 table in my clone database. And I want to clone that employee table also there. Okay, so we have in clone matrix database, we have a table employee 2, which contains exact same data. Now let's go back to this one screen and understand. You have a scenario, employee metadata. Underneath, it is stored in the micro partition. So what is micro partition? That how we have a by default, when you create indexes or the tables, right? There is like a row level partitions when you think about that. And here in Snowflake, there are column level partitions. So there are tables because there are no indexes here. So the internal design, the physical structure is the compressed pages are in the columnar level in those micro partitions. So your employee table is even whatever the micro partition is. When I create an employee 2 table clone, this is a employee 2 table is a pointer to employee 1. So at this stage, just assume that I am managing employee 2 and my employee 1 is a 10 terabyte table. And I clone employee 1 to employee 2, you do not need another 10 terabyte because employee 2 is a pointer to employee 1. However, now I'm making some changes in employee 2, right? Because I want to like overwrite my bad table employee with there is some data problem. So my currently I'm working on employee 2. It's a different micro partition. If you make changes in which is in the new micro partition, it would not go back and replicate things back. So you might be having this micro partition of employee 2 with the which is the linked to employee 1 employee table original table, and you can have some different data here. So as a developer, engineering teams, they might be creating multiple clone tables, and then they might be working on the data changes and eventually finding the right model and the changes and then deploy this back to employee table. Fair enough. But during that process, that is the concept of the clone table architecture, that within the underneath the storage layer, you get a pointer of another micro partition, and you do not need that all 6 or 10 terabyte for that in order to clone the tables or clone the databases. So I know this is a bit like when you actually get in hang of doing this thing more and more, you get fair idea, but from high level, that's the understanding. Yeah, somebody said this is like a snapshot. You are right, this is like a snapshot. Fair deal. Let's go back where we were doing. There you go. Now, okay, during my journey, now my matrix database, what was the retention? 10 days. And what all tables we have? Okay, so I just have to hover I keep forgetting, keep selecting things and all that. So I have currently, since we clone employee 2 also, so I have one in, okay, see, um, little, I should have done the first command, use matrix database. So let me go back, and we don't need this much statistics all the time. So this is the scope of the database, or you click on use database. A lot of things are very similar to T-SQL. That is why for a SQL Server data professional or the database professional, Snowflake is the next step and the easiest one. Because we just feel very comfortable with this whole thing. We just have to do a little bit of hands-on and we are like all rolling here, rolling on, and we can deal with this thing very well. So in this one, when I do show tables, we have employee orders, transient orders. Transient orders would be life is just 1 day, and orders table by default I created with the 1 day retention, and this guy employee is the 10-day retention, and clone employee. 1 minute, I don't think this is the one that is in the clone database. Why don't I just do this thing for now in order to save some time? So I'm going to drop my employee table. Okay. And that sometimes can happen. We do live that life where by mistake we drop. And when I drop this employee table and I go and check, okay, I lost that table. I had 10 days of retention. Now, good thing is with the regular tables, you can undrop the table. So I click on undrop, and it was part of my regular table category. So undrop happened, and then like I'm back to my show tables, and employee table with all the data, everything is back. It's here. So this is about high level drop undrop, some idea about the database and the time travel, fail safe, type of tables, type of databases. Any questions so far? Okay, I take it no. So let's
It's
move.
7 minutes, Surbhi.
Yep.
Time check.
Let's do the 5-minute thing on creating the. So I was talking about creating the share, right? And what do we mean by creating the share? So you have a proper, like, these are the options. Let's go. Like, why I'm torturing everybody just with the words and not visual. So we understood the databases. What are the databases? We create databases, right? And you can add data. This is all external, and then since it is like a cloud agnostic, you get like all type of options, right, from the Google, AWS, Azure, and stage, and into tables and everything. So this is the add data. Then comes the data products, where marketplace is more for you want to build a solution of data and then share it with people, and then and have that, like, let them buy your solution. Or in my case, what is the scenario I have? I want to share by account. So I have a finance department, an employee table and salary table and everything. And then I have a reporting account. Remember I said about this thing, org admin. So this one, account admin. I'm account admin for this particular account, and my org admin, my CFO, he needs to run certain reports. So org admin, oh no, this is not a great example, but there are finance department, other people, they just need to run some reports. So I just want to create a share of a table, employee table. I don't want to give them access to all the tables and everything. So in that case, they can be a separate Snowflake account, which is completely different world. And then in that world, they can do whatever they want just with the read-only access, and they might get from all the entire organization. They can be shared with their account for all the reporting purposes. So that's like an enterprise reporting account. So in that case, I go back to my worksheet, and this is cross database share. Let me quickly create this finance DB, because this is the department. And I'm creating, so I'm just giving you a little bit of idea about roles and permissions, because we will just high level. Oh, so this role and this particular user already exist. Okay, fair enough. I missed dropping things, cleaning up a little before, but we have 4 minutes. So what, we have this database. Let's move towards at this stage, I don't have any table, and my current account is with the in currently, which is my Surbhi account. I do have no share, right? So I'd like show shares. I do not have any share. So it would say these are the default ones. So let's not call them that you have shares. So then I create one fin data share. When you create a data share, I'm creating this data share in the finance database. Okay. And after that, I have to grant a certain type of permissions. So all the uses of finance DB, finance database, it has the access to finance data share, fin data share, which I just created. So when you create this data share, and I'm going to give it like a complete schema access also. And now within the finance DB, let me just create another employee table and insert some rows and select data from this. So what is our objective? In my finance DB, I might be having 20,000 tables. I just want my reporting account to be able to access this table via this share. So that means it's a private share, remember? So now we go back, we created this share. So in the private sharing, share by account, it would come, just let me finish that one more step, and then it will come here. Uh, the another account which I created, their account number is this is that account number. So I'm going to alter the share and grant this particular share the access to other account. Okay. Now this particular share contains all the privileges on employee table. There is a mistake here. That's okay. We can do this. Okay. And my current account, the master account, what I have currently, this is my master account, IE836. I go to the private data share my account. Just this thing, sorry. Yeah, so fin data, this is bit because I'm running on the single node credit, so it is bit slow. So you got in finance DB, this is the data share. So for each of your organization's databases, whatever needs to be shared, you can create this kind of share. Now, when I create this share, I go to my reporting account because I just have to make sure that the master account share, which is fin data share, can be accessed from the reporting. So I am creating a database here on my other account with the create database, which is from a share. So as soon as this is sort of, you can think about this as a linked server in linked database in SQL Server. So you created that. Now from my reporting account, when I select on fin data one public, I get the view of my employee table. So this is my reporting account, and I can see my, and this one is like, different account, but I can see my fin database, financial database via fin data share. So this is a private sharing. So public sharing, private sharing, and then sharing with the authentic, the other sources. Those are the things we can do that. Now, the last, even we are not doing the demo for materialized views or views. In Oracle, there are materialized views. So in your scenario, views we all understand. In SQL Server, we have views, regular views. You have a three table, you do a join, and then you have a select, and that is the one which is your view, and you run your reports or whatever the query. But those views always are pretty resource consuming if you are executing that pretty often. And here the materialized view will be using the underneath, creating a physical table for that. So from the performance perspective, a view can be handled much better when you do that via materialized view, which is mostly an Oracle feature, not the SQL Server, but this is another aspect. So when we go back, we understood the micro partition and then cloning architecture. Access control, we understood high level, account admin, security admin, sysadmin, public and org admin, etc. These are the roles which are something like we created a user role. We did not go in those detail and the governance aspect or the data classification, but high level, it also there is a hierarchy of users and then access matrix. You can go with that. And the recap with how we started, we understood the introduction about the basic architecture, concept, clone table, data types. No, not exactly too much of data type, but we understood all the aspects from the foundation and how the database and tables with all the options can be created. And we did obviously during the journey, like SQL Server is in our DNA, so we do keep compare with that. So this is all about you can get going with your Snowflake journey, and this must hopefully this is a kickstart in your journey to understand the concept, architecture, database tables, and thank you very much.
Thank you, Surbhi. That was really awesome. If you can also hang around for a quick second after this. So guys, if you have any questions, this is a good time to do this. Even I'm going to give her a nice round of applause. So for those who want to come to Houston, she is going to be doing Snowflake 101 and 102 before and after lunch. So that's an in-person event. Would love to see you guys there. It won't be 100 degrees outside, I can promise you that. But yes, let me stop the recording first and then we can take questions. So